This is a pre-built version of the application. So if we go ahead and run it, and we will be using a standard deck of cards to go over independence and conditional independence. So here we have 52 cards, 4 of each type, so 4 aces, 4 kings, 4 queens, etc. And we have 4 suites, a club and a heart and a spade and a diamond. And we have 13 cards in each suite. And clubs and spades are colored black, and hearts and diamonds are colored red. And in each suite we have 3 faces, a jack and a queen and a king, and 1 ace, and 9 numbered cards, 2 to 10. And we can do probability and check independence without replacement, so the card is not put back in the deck, or with replacement, where the card is put back in the deck. And for the purpose of this tutorial, we will only be doing with replacement. And let's start by checking if the rank equal ace is independent from the color equal red. So we have 4 aces in a deck of cards. So 4 out of 52, which simplifies to 1 out of 13. This is the probability. And the probability of having color is red is 1 out of 2, since half the cards are red and half are blacks. So we can have 2 aces that are colored red, so 2 out of 52, which simplifies to 1 out of 26. So to check independence, we check if multiplying the probability of rank is ace and color is red is equal to the probability of rank is ace and color is red. And it is equal, so if we multiply those two, we end up with 1 over 26. So rank is ace is independent from color is red. And let's try rank is 10 if it is independent from type is face, and it is not, it is dependent on type is face. And the reason is that those two events of rank is 10 and type is face are disjoint, so their intersection does not contain any cards, so the probability of rank is 10 and type is face is equal to 0. And if we multiply those two, here it is different from 0. And let's try one with conditional probability. So we want to check if rank is king is independent from suite is spade, given color is black. So color is black, we are limited to the spades and the clubs. So probability of rank is king and suite is spade, given that color is black, is 1 out of 26. And the probability of rank is king given that color is black is 1 out of 13, and of sweet is spade given that color is black is 13 out of 26, which simplifies to 1 over 2. So if we multiply those two, we get this one. So rank is king given color is black is independent from sweet is spade given that color is black. Now before doing the code, let's go over independence and conditional independence. So events A and B are independent if multiplying their probabilities, so probability of A multiplied by probability of B is equal to the probability of their intersection. Or another way of stating this is if the probability of event A is not affected by event B happening, and we have the probability of B bigger than 0, since from the definition of conditional probability, the probability of A given B is the probability of the intersection of A and B over the probability of B. So this cannot be 0. And same for probability of B given A. And for events A and B being conditionally independent given event C, so the difference between this and regular independence is that we add C to the given side. So probability of A intersection B given C is equal to the probability of A given C multiplied by the probability of B given C, where the probability of C is bigger than 0. And the probability of A given B intersection C is equal to the probability of A given C, where probability of B intersection C is bigger than 0. And this is also equivalent to the probability of B given A intersection C is equal to the probability of B given C, where the probability of A intersection C is bigger than 0. And we can generalize this to more than 2 events. So for 3 events, we have the probability of events E1 intersection E2 intersection E3 is equal to the probability of E1 times E2 times the probability of E2 times the probability of E3, for those 3 events to be independent. And we have to have that the probability of E1 intersection E2 is equal to the probability of E1 multiplied by E2, and E1 intersection E3 is equal to the probability of E1 times the probability of E3, and probability of E2 intersection E3 is equal to the probability of E2 multiplied by the probability of E3. So in general, events E1, E2 through En are independent is equivalent to say that the probability of the intersection of those events, where I is in a subset S of 1 to N. So this is equal to the multiplication of the individual probabilities of each event for any subset S of 1 to N. And independent events must be non-disjoint, and conditional independence does not imply independence, and also independence does not imply conditional independence. And events A and B are independent is equivalent to say that event A and B complement are independent, and also A complement and B complement are independent. I will start by creating a new project. And here we will need this jar file that I used on the previous tutorial to do fractions. So we go to properties and Java build path, and here we will have 5 classes. A driver class with a main method, and this will be driving the application, and this convenience class that will contain the data used in this application, and this class that represents an item in the data. So in the case of a 52 deck card, it would represent a card, and this class that represents a subset of the sample space. And this class that will contain the probability and independence check logic. And this is the data of a 52 cards deck. And this is heading, and those are the 52 cards in the deck. And we will define the sample space omega here, and an item will have a hash map of features, and a get method for that, and this will be initialized in the constructor. And the features are the rank, the suit, and the color, and the type, and the sample space. And here we will populate the sample space, and this method displays the item in the sample space, and an event will contain a subset of the sample space. So it will have an array list of items and a get method for that, and those two static methods will create and populate an event from an array list of items or a hash map. And this method finds the intersection between this event and the passed in event, and returns a new event containing that intersection. And going back to the driver class, This method will handle command line entry and interacts with the user, and this method and this one, they will both handle probability calculation, and this one will handle checking for independence, and we will call the display items and the handle command line from main. And going here, we'll have those two methods that do entry validation, and this method prepares and returns an event from an array, a string array of values, and those two methods use the prepare event method to do probability calculations, and this one calculates the probability of a union, and this one checks for independence, and this one checks for independence with givens, so conditional independence, and this is the code for handling command line entry. So depending on what the user entered, either we do independence check or we handle probability calculations. So this one handles probability calculation without a given, and this one handles conditional probability calculations, and this one does the handling of independence check. And for convenience, let's add this information about a standard deck of cards. And let's go ahead and add independence to the name. And finally, let's go ahead and test run the application. So let's check if rank is king is independent from type is number. So we have two disjoint events. So rank is king is dependent on type is number. And let's check if rank is ace is independent from sweet is heart, and it is. So we have 4 aces in a 52 deck card, so it simplifies to 1 out of 13. And we have 13 hearts out of 52 cards, so it simplifies to 1 over 4. And we have 1 ace of heart, so 1 out of 52. And if we multiply those two, we get this. So both of those events are independent. And let's do one with conditional independence. So I want to check if rank is king is independent from suite is heart, given that type is face. And it is independent. So type is face. We have 3 in each suite. So 3 times 4 is 12, and one of those 12 is king of heart. And we have 4 kings in those 12 cards, so it simplifies to 1 over 3. And we have 3 hearts in those 12 cards, so 3 over 12 simplifies to 1 over 4. So multiplying those two gives us this result.